Okay, howdy guys, welcome to LE1. I want to go through a quick PowerPoint and then the starter code to get you set up for coding LE1. Now this exercise is building on top of what we learned in week 1B specifically, where we went over exec, fork, get opt, all that good stuff. We are now going to put it in practice with an exercise. So let's go over PowerPoint first. So like I said, LE1 requires creating child processes using a fork. So you're going to create two processes. They will run two different commands. You are going to pipe the output of the first command into the input of the second command using an unnamed pipe with dupe2. And we are going to be running these commands using the exec VP. So I would like to reference back to lab material from week 1, specifically 1B, if you have a question about commands, also going through more examples in depth. So expectations for LE1, we want to run ls and the tr commands so that all of the files that are in your working directory are displayed and in all caps. Requires running two commands. You run both of these as children of the main shell. And then so that you're able to translate the output of ls into all caps and output it to the terminal, that you need to create a pipe, create an unnamed pipe like we talked about before. And then we gave you some starter code. So it's very simple, more of a skeleton starter code. You don't need to add any additional parameters to the main program, but I am going to give you carte blanche. You can modify, add, delete any functions that you think that you need. And in general, I say that as long as you're not changing the public signature of any of the provided starter code, you are free to change it. Okay, so resources for the lab, like I said, week 1, here's a link to lab 1B. And then man pages are very helpful. I will show you an example of using man pages in a bit, but those give you a description of the command and examples of the command as it's installed in your system. So it's very system specific. Sometimes you get commands that change versions, and those versions change how you use the command or what parameters you need to pass in. If you use the man pages, you get that specific version's help. So it's always a first thing I go to. And feel free to Teams, DM, and go to my office hours. So let's do an example of using man pages in Linux. So man stands for manual, and you can look up manuals in just in the Linux console without needing to run a Google search. It's actually pretty helpful if you just need some quick information, some quick examples. And this is the programmer has used their documentation, and it's what they want you to know. So if we go and type in man for get opt, you can see the first page of the get opt manual is shown. And you can tell what section you're in by at the top here, it'll give you colons or parentheses. And inside of those parentheses, there's number, that number is your section. Some commands will have multiple sections, and you can select which one you want based on options to the man command. But reading through this get opt manual, you can see there's a description, parse options in the command line. It'll give you all of the options that you can do for that command. Maybe some more details about how to parse, compatibility, some bugs, author, see also. The see also is helpful too. It'll give you related commands, maybe better suited to your project. But let's show if you did a man page of, say, section 3 for get opt, you'll get different information. So since this is programmer specific, the pages vary between commands. But for this one, Previously, we got more of the command line get opt. Here we're getting the how you would run it in a program, more of the API section of get opt. So you can see what library you need to include, and you can see what parameters that get opt takes. A lot of times, if we scroll down, there's going to be descriptions of each parameter, and also descriptions of the return value. So yeah, here's descriptions of each parameter, and then the return value. So man pages are very helpful, if only to show you what libraries you need to include. So if you see a red squiggle underneath and it says undefined function, check the man page, see if you're missing an include. That's the first place to look. Okay, so let's get into code. So here's the main function. As I said, it's pretty bare bones. You can see that this is the ls command, and here's the tr command. And if we were to run this in the terminal, let me just pull up a terminal, this is what you would see. So you would see ls, pipe it to tr, and let's get the parameters correct. Yeah, let's go through all of the parameters. So -al, so A will show you all of the files, including hidden files. L gives you additional details. The / indicates that it's the root directory. Then we pipe it, so the vertical bar is a pipe. We're doing tr, A through Z. So all lowercase instances of A through Z will become uppercase instances. So we can see this output, and you can tell that all of this output is from ls, and it's been converted to all caps. So if I were to just run ls by itself, it's all pretty much in lowercase. So tr is translating it from lowercase to uppercase, and everybody's system is going to give a bit of a different output, which is fine. In Git, the output will be the same because the file structure is the same. So know in advance if you have a friend that has a different output than you, that isn't necessarily a bad thing. Okay, so those are both commands that you will need to be using. Okay, and then now let's get into what you need to implement for LE1. So the first thing that we do is create a pipe. We do this first because we want both of the children to be able to reference the same pipe. If we were to create the pipe after running a fork, the children that you created before the fork would not, or before the pipe, would not be able to reference the same pipe. So we create it first. And this is just using the pipe command. Look at what parameters it needs and what it returns. Next, create the first child. This is just fork. And you'll need to remember how to tell if you're in the parent, which is going to be the main shell, or the child. So in the child specifically, we're going to be redirecting the output. And here, so Duke 2 specifically takes two parameters. Know which parameters they are. We want to redirect the output, so standard output, to the right end of the pipe. So check those out. We want to close the read end of the pipe, and that's just going to be a close command. We do this because if you have a pipe that hasn't been closed on both sides, both the child and the parent, they're going to stick around and not allow the main process to complete. And then in the child, execute the command with execvp. Okay, so once you've set up the first command, command 1, we're going to run the second command in much the same way. You don't need to create another pipe. We're going to be using the same one, but you'll want to do a fork. Same things apply. Read man pages and our videos. Redirect, Duke 2. Run a close. And exec the second command, exec VP. So very, very similar. The main differences are going to be how you're using this dupe2 command. If you have questions, please ask me about that. Last thing, reset the input and output file descriptors. While it's not completely necessary to do this here, since if you do this correctly, you're only redirecting the input and output of the child, it's still good practice. We want to leave the shell program in the same state that we got there. So this is going to require us saving off the original standard input and standard output. So we're going to be doing this before we've created the pipe or anything. So save original standard in and standard out. And this is where we're going to be using the dupe command. So we're going to be doing it twice, once for standard input, once for standard output. And then here, this is going to be using, so overwrite in, out with what was saved. Here is going to be using dupe2. The difference between dupe and dupe2 is dupe will save a file descriptor that you give it to the first available file descriptor, and dupe2 will take a target and a source and move the source file descriptor into the target file descriptor. I like to, and if you're familiar with this, feel free to end the video here, but I like to go into Excel and give you and show you what a file descriptor table looks like. So in a file descriptor table, we have an index, we have a label, yeah. So the index will not change. These will stay the same. You can say value and label here. So by default, we start with three file descriptors, one for standard input, one for standard output, and one for standard error. We're going to be mostly focused on standard input and standard output. So whatever is in this cell here, will the process will read in. It'll treat that cell as its input, and whatever is in this cell, the process will send its output. So by default, it's standard input and standard output. Those are both the terminal. By default, it goes to the terminal. When we do a dupe2, or let's start with dupe one, just dupe. When we do a dupe, what you do is you give dupe an input, and it will assign to the next available index. So the next available index in this case is 3. If we performed dupe on index 1, it will copy whatever value is in that index and stick it in the next available index in your table. If we did another dupe, if we did a dupe of 0, the next available index is 4, and it'll take whatever is in this cell and stick it in the value of the cell that we just mentioned. So that's how we save everything off. So now our standard input and our standard output have been saved using dupe into index value, the indexes of your tables 3 and 4. Next, if we open a file, for example, you're not going to be opening a file in LE1, but it's helpful to talk about. So if we open up a file, it will also assign the next available file descriptor. End quotes. So opening up a file assigns the next one. Let's say the value for this is file 1. Now, if we use dupe 2, we can move, or we can copy the value of that file into either standard input or standard output. So say we want to write the output of our process to the so say we want to output the process to a file, we would use a dupe 2 to set this file to our standard output. And that would look like this. So we dupe 2. And dupe 2 is target, comma, source. So our target is going to be 1. And our source is going to be 5. So we're copying whatever is in 5, which for this example, it's file 1, to the index 1. And then you can see at the end of the process, if we wanted to, you can reset by doing another dupe 2 from 1 or from 3, which is where we've saved off, back to 1. Okay. So you are going to be complete with LE1 once you run it and have an output that looks like this. There'll also be a test on Git when you commit. Good luck, everyone. Please reach out if you have any questions, but thank you very much.